Well, basically, this is about how I'm trying to use LCC on my railroad. And I said part one because later on I'm going to do another presentation on how I actually configure the stuff. And tonight I'm going to talk to you a little bit about theory, and if it gets to be too much, say shut up and move on. And um, going to try to show you some of the pieces and parts that go together to make it work. So we've heard about it. It's been going on for what, 8 years or more, and it was developed by a volunteer group, and it's based on the CAN bus that we know is all in our automobiles. And they chose it because it's extremely fast. I mean, you don't want to step on your brake pedal and not have it work immediately, but it's very resistant to static and interference. And anyway, it can control all your layout functions, and except for the controlling of the trains. And it really takes the burden off of DCC. So the DCC can just be used to run trains. It was developed because the thought was they were trying to control too much. And DCC is a collision-based technology. And then there are other systems that were developed like CMRI and LocoNet and some of those things, but they're mostly master-slave type solutions. A lot of them require you to have a computer running in order for them to work. So neat thing about the LCC is you can put a node anywhere on your layout, and you can set it up. And I'm reluctant to call it programming because it's not true programming. You're basically taking some hardware and going through some menus to configure what it does. All of these boards, these node boards, come with addresses on them, like a MAC address on a computer, so that they can never be duplicated. And the manufacturers all have, I think it's an 8 or 10 digit number separated by dots. And the first, I think, 6 numbers are I guess, assigned to that manufacturer. So everything they produce, it's going to have those numbers on it at the beginning. And why that's important is, as I talk about events, all the events start out with that manufacturer's numbers, and then have numbers that are germane to the board itself and its activity. So here's kind of the idea for DCC. The idea for DCC is that you run trains, multiple trains, but LCC, you can still run those DCC trains on the track, but you can run a lot of different things. You can run switch motors, you can run signals, you can turn semaphores on and off, or make them work. You can turn lights on and off too in buildings and that kind of thing. So like I mentioned earlier, it's noise tolerant. It's a universal standard across the world. It's very high speed. The guys that designed it set it up to run on up to 1,000-foot bus, and that's bigger than most of the railroads that I've seen. So it uses Cat5 cables and connectors, so it's easy to put the components together, and it's not collision based like the other peer-to-peer systems. And the only time you're required to use a computer is while you're configuring it. So anyway, a lot of people say, well, can I have a star network? Can I stick the nodes in the middle of my layout and then go out from there? Well, you can't do that. It's node to node to node as you're stringing the Cat5 cable together. Now, each segment of a network is limited to 40 nodes or less. And but there are repeaters that you can hook up that basically restart the 40 count. One of the things that I've found, and anybody that knows me and heard me talk about LCC, I've complained about it a lot because startup is difficult. I don't care what the LCC guys in the videos tell you. It's so many foreign concepts, and it's a pretty detailed thing, so it can be hard. So it's great to have a group IO that we can refer to, and you can always call the manufacturers. They've all been really helpful. So everything that happens on an LCC network is about the events. It's driven by events. And some events are created by producers and some are consumed by consumers. So nothing happens on the network until something happens. So somebody pushes a push button or a touch trigger. Like on my layout, I use a lot of touch triggers. Or a block detection device detects presence of wheel set that's drawing power. Consumers can be, lamps or other things to control, and they're not constrained. You can have 0 to 1, 1 to 1, or you can have 1 to many different producer and consumer events. So here's an example of that. So this is a 1 to 1. It's you push a button, turns a light on, or you push a button, turns 3 lights on, or you got 4 different push buttons that can turn lights on and off at different times. And that's all controlled by how you set it up. It's pretty simple layout, wiring. It doesn't complicate what you're doing. Most of us have like a DC bus for 12 volt for like lights and stuff. We have our DCC bus, wireless and otherwise. And we've got, connections to turnouts and things like turnout motors, things like that. But the wiring is pretty short. I mean, most of my wires are a foot long, except when I'm taking a signal someplace. For instance, I have all my tower boards mounted behind me at the helix, and they're centrally located. But as it goes out from here onto each lobe of my railroad, I've got it goes to one of the IO boards, and from there wires may go out and run 20 feet or so. But like from the detection devices to the IO boards, I use like a foot piece of Cat5 cable. Everything's active on power up. Can't really show you here, but there's this APC surge protector hooked up to my board that everything's plugged into. And when I turn that on, the DCC system comes up, all the LCC things are live. I can walk up to any turnout, I can push the touch toggle or touch it, and it'll throw the turnout. I mean, and it's pretty much instantaneous. So this was a sample. This is off Railroad Circuit's website, where you can see down at the bottom in the center, you got a computer that goes to a LCC buffer. From there, it goes to nodes via Cat5 cable. And, you can see where the tracks are at. There's some signal icons, and there's some little things that look like tombstones up there that look like a wire's running through it. Well, those are feeder wires going to different blocks. And you can see the curlicue wires coming back to one of the boards. That's an IO board. And that's to represent twisted pair wire that you strip out of a Cat5 cable. So basically, you've got a power pack on one end, you've got a USB connection to a computer, and from there, it's network cables. In other words, Cat5, Cat6, Cat6E cables going from node to node. And each node then will have different types of IO boards connected to it based on what you need to do. So here's an example of a starter kit. You can see there's a power supply. It plugs into this power point. That's what powers up the CAN bus, the LCC bus. you got a terminator. It comes with two terminators, so you have to terminate the beginning and the end of it. It's like, it's like a water hose. You hook it up to the house, you hook it up to your spray nozzle. If you take one of those off, it's all going to run out, so it doesn't work right. So this is the same thing. And then this is a picture of the USB buffer, and it just uses a simple USB printer cable to hook up to your computer. My computer is back behind my bar, so it's about 16 feet to my computer from this board that's right behind me. So I had to get a powered USB to USB cable to boost the signal to go up and over, but it's been uber reliable. I haven't had any problems with it, with connectivity. This is the repeater product that I talked about before. When you get more than 40 nodes, or if you've got too many things drawing power on the bus, Railroad Circuit sells in the lower right corner, you can see the LCC vamp meter. It'll tell you how much power is on your CAN bus at all times, and it mounts right in the fascia if you want to use something like that. But I think you got to have a pretty dang big network to go over 40 nodes. I mean, right now I've got enough, and I'm only using 5 nodes, and that's to do my whole top deck of my railroad. So one of the nodes is the Tower LCC plus Q. It has 16 I/O lines. So you can see on the left side of it, that's where your Ethernet cables plug in to daisy chain them, or an Ethernet cable and a terminator if this is the last node. You see the 10-pin connectors. The center connectors are positive and ground, positive 5 volts and ground. The other ones are data lines. And you use flat 10-pin ribbon cable with IDC connectors on them, and you plug those in, and that goes from this board to one of a number of I/O modules. So this is like the controller. This is where you actually set up the interaction between all the boards and all your peripherals. The main chip on this, the largest chip on this, houses the CDI. And that's what's used to configure the boards. So when you go into JMRI, once you've connected your CAN bus to JMRI, a menu item will appear that says LCC, and you pull the menu item down and say configure nodes, and then all of your nodes will show up instantaneously, and you click on it when you say open node, it'll show you all the different and I'll show you this in a subsequent presentation exactly how it's done, but it shows you all the different selections of how you configure these devices. And you will actually see for each one of these connectors, there will be lines 1 through 16. So, if you want to configure line 1 for like occupancy detection or something like that, you'll go in there, and I'm maybe getting too much of a preview, but it'll, you name it. Like I would name mine West Approach, LaPorte, Indiana. And then you would configure it. Well, that happens off of this board, off the chips on this board. Now, another one of the nodes is a signal LCC. This one, again, has the 2 connectors on it, but you can see the notes there. It says, here's a screw header for the various signal heads. So you can run 4 signal heads off this board. Up to 16 aspects can be controlled off it. And the logic for controlling those is on this board, again, in that largest chip that's on the board, gets configured in the CDI. This board can come with screw headers, or it can come with pins. If you like to use, pre-made cables that have pins on them, or you make your own, that kind of thing. So now I'm going to talk about some I/O boards. This is an I/O board that's very popular. It's the BOD4CP. So basically, it's 4 detection blocks and control of 2 turnouts with it. So if you look at it, where it says number 1, on the diagram, that's power lock. Power lock's a feature built into these LCC boards, whereas if you have power lock enabled, you will bring DCC over from your bus and it'll plug in here. Your typical red and black wires, or white and black, whatever you use, blue and green, whatever. They'll plug in here, and when it detects that drop in that block's DCC signal, it'll lock the occupancy of all of the devices that are hooked up to it, which is a kind of neat feature. Because, you know, the position of your turnouts and their indicators, like me, I use touch toggles or touch triggers. So when I touch that thing, I want it to go from green to red when it's going diverging. Well, if power drops out or something, then I want it to stay green or red. I don't want it to be mixed up. Okay, so that's what that's for. And then there's just a jumper right next to it that sets it on or off. The number 2 is the input for the CT coils. So these are the little CT coils over on the left, where you run the wire for your DCC block through these, and they connect here. 2 wires for each one, because there's 2 little feet on coming out of each one of those. So that has to go back to this board. And if you use a stripped out Cat5 cable, the colors of the wires that come out of there are orange and orange white, blue and blue white, brown and brown white, and green and green white. So it's it's a perfect match to use those. A lot of people will solder those Cat5 wires onto those CT coils. I have a handy little connector that's a spring connector that exactly fits those coils, and I spring it onto them, and then I can use a spring connector to just connect the wires to this board. Now you'll see number 4 there, it says pots. Well, each one of these blocks has this little screw thing on it. You can increase the intensity of it on that. Okay. I just, on the end of the board, you can see 5 volts. If you need to grab 5 volts someplace, you can get it off the board. I found that out just by messing around with it. So your switch machine terminals are over down at the bottom. Positive is the center, and then 6 and 5 and 8 and 7. Those correspond with the, remember I talked about the IDC connector has lines 1 through 8 in it, or well, it has lines 1 through 8 and then positive and negative power. So those correspond to that, and I'll show you that later in an example. Because this board pushes turnout machines, you got to bring 12-volt power in. So to each one of my industrial districts, I have 12-volt, 3-amp power running into that district, and I just bring a wire pair over and plug them in here, positive, negative. The input lines, I don't use those. You can hook buttons and things up to that. I don't do that. I do it a little bit different way. So anyway, so that's probably everything you do or don't want to know about the BOD4CP. Another I/O board is SMD8. This is just for driving stall motors. So you can plug this into a tower LCC or a signal LCC, and you can drive up to 8 stall motor machines. If you have a complicated interlocking or something like that with a lot of stall motors on it, you might even dedicate one of these boards to that purpose. And you can see from the diagram to the left of the picture of the board where you bring in your 9 volts or 12 volts DC into that board, again, to drive those turnout motors. The next one's a BOD8SM. This is for detecting, just like the BOD4CP. This will hook up, as you see the diagram to the left, CT coils to all the screw terminals. You can hook up 8 detection districts up to this. And it also has the power lock feature, you can see. These are some of the supplies that I've used. So I got the Berry Hill touch triggers, 24 gauge or thicker. You don't want to use anything thinner than 24 gauge because of the integrity of the signal. I use colored ribbon cable for mine. They sell gray too with a red stripe on one side. I just find it's easier. Plus, I use that cable for other things. Here's the IDC connectors. These terminal block splitters are really handy. I get them from railroad circuits. You can get them anywhere. One of the things I use these for is I come off my 12-volt bus underneath my layout, and I come off right into these, red and black wires into red and blue. And on the other side, then I can hook wires up to go to buildings to light them up off that. And if I need to put a resistor in, I just shove the resistor, one end of the resistor, into one of these and clamp it down, and then put a WAGO connector on the other end and send it out. That way I don't have to do any soldering. I don't do any soldering under my railroad at all. Everything is done with electrical connectors. So over here again, you see over to the right, you see the CT coils. This is a cable that they sell that hooks up to NCE command stations, because some of us with older NCE equipment, they have a 9-pin connector on them. This is a neat little board. It's called the Bob S. It's a breakout board with screw terminals. So you can see here's our familiar 10-pin connector. So you would put an IDC on your way, on the ribbon cables on the way from the node to one of the IO boards. And in my case, I use BOD 4CPs. You can clamp an IDC connector onto that cable and then plug it in here. And then you can use those screw terminals to hook up things like switches, like touch triggers or momentary push buttons. The breakout quick link down here in the lower left, that's a similar device, but it allows you to go flat ribbon cable in and flat ribbon cable out. And then you can use these Berry Hill touch triggers, which you can see they've got servo cable on them, and they just plug into that line, and then you program for that line. Or Railroad Circuit sells lit push buttons with cables that plug into this that can be configured to run push buttons off your fascia. So here's an example of a test bed where I'm using a lot of those different things. So here's a BOD 4CP. This happens to be a signal LCC. You can see I've got the Ethernet cables hooked into it. I've connected up a NCE power cab to it. I use these little MP1 switch machines. I use them because they're 1.5 inches by 1.5 inches and a 1/2 inch thick. And they nestle down right into the 1-inch foam that I use on the top of my railroad. So you can see from this switch machine, I've got wires coming in over here on this side of the BOD 4CP. And there's a positive and there's a positive and positive one that switch with the pushing of either this momentary push button or this touch trigger over here. And so those are hooked up that way. And then my 12-volt power is coming in right here. And then over here, I've got a piece of track that's got a CT coil on it. Sorry, it's a little blurry, but it plugs in right there. And then over here, this is the Bob S. See how I've got it clamped between the two boards, between the node and the IO board. And then the positive and negative are here, the brown and red. And in this example, the orange wire is the one that causes something to happen. So when you push the button, the signal goes down the orange wire and back to the board, and it tells it, hey, throw that turnout, throw that switch machine. And the same thing with the touch toggle, does the same thing. Now in this case, this is a signal board, and I've got some of these cheapy signals from Seth Newman's company, Model Railroad Control Systems. They're really uber cheap if you just want to get started up with signals before you invest in them. And I used ribbon cable that has pins on each end of them, so I could screw them into screw terminals and plug them into the back of these signals. And so they're red, yellow, green, and then white is common anode. So I don't know if it's going to work, but I'm going to give it a shot. This is just show you that this stuff does work. Back to green. Now we've got a wheel set sitting over here on the helix. And there's the BOD4CP. When I take the wheel set off, the detector light goes out, goes on, off, like a little kid playing with it, right? And then that's the end of the video. Questions?
On the detection, do you need resistors then on all the trucks?
Yes. Yeah. And I've been doing that. I'm off the top of my head, I forget who I'm buying them from. Logic Rail Technologies, maybe.
Okay.
But
You do need resistors. Okay.
Yeah. If you got a lit caboose, and obviously a locomotive, that'll draw the power down. But yeah, you need resistor wheel sets. And right now I've got 80 or 100 sets that I need to redo my cars. But I plan to put one set on the outboard ends of the trucks on every car. But you don't have to do that. I mean, you can do it other ways, but if you want true detection, that's what it's going to take.
I'll ask one other question. And what would you say is your basic cost investment for you to have got going on the LCC?
Well, that's a good question, and I'm going to give you probably a longer answer than you want. I started out with LCC a number of years ago and decided to get in early and bloody my nose. So I thought each peninsula on my railroad is basically 20, 25 feet long. There's a turnout at each end. So you got an approach on an east and west approach, a main and a siding, and 2 turnouts. So I know the BOD4CP will control 2 turnouts and detect 4 blocks. So I only need one of those, right? Well, back then, not so much, because the only way to run signals was through the signal LCC. And that only covers 16 aspects. Well, if you count a double-headed signal at each end and 2 intermediate in between the turnouts signals, and I use snowhead signals, so they're all 3. So that's 18 right there, and that doesn't account for dwarfs coming out of the siding. And so that was what I thought I needed to do at the time. With that kind of schema, I needed a signal LCC and a BOD4CP on each end, and I had lots of unused capacity, and it was going to cost me $200 a section for the electronics. Okay, well, they've since come out with a signal controller called the Signal LCC 32H that'll control 32 signal heads. And instead of it having that gangly of wires coming out of it, like I showed you, each signal, it starts with a board, and it goes to the first signal, and there's a board that plugs in there, and this is all servo cables too, so it's easy to run. you plug them in there, and it's got four screw nuts on it: red, green, yellow, and common anode. Okay, so then you just go from that one to the next one. So and the boards in between for each signal head are only like $68 a piece. So what I did is I sold off all my old LCC stuff. Kind of got ticked off and fed up. And about 5 months later, discovered this simple signal serial bus thing and decided to get back in. So I had about, I don't know, $1,100 in it at first. Interestingly, I got all my money back out of it. It's the stuff I could reuse it. There's a real healthy group IO that's very, very active. And I just put it up there and the guys bought the stuff. And they didn't quibble about the price or anything. And I charged them what I paid for it. And now the other stuff that I bought is a lot less expensive because I need less of it. So it now is, I've got a tower board. A tower board will control two industrial districts, okay? And for each industrial district, I need a BOD4CP. So that's $35. The tower board's about 60. So I need 60 and 70. It's $130 every two peninsulas, and I've got 5 on the top deck. So that's not too much. You add the signal boards, but I make it more expensive by not using push buttons. I use the touch triggers, which are more expensive because I'm an electronics geek. And the lights look pretty. So it started out real expensive, but I don't think it's so bad anymore. I mean, it's, I probably got as much in it as I would have a couple of locomotives and a couple of nice cars. And I bought enough to do my bottom deck at the same time. So now I got all the boards and stuff I need, all the CT coils, all the ribbon cables, and all that stuff. So the next time I get the presentation put together, I'll show you guys how I actually configure it and that kind of stuff. So.
Very cool. So you basically program it through JMRI, right?
Yeah, you go into JMRI, you go into Panel Pro, and that'll be something I'll show next time. You go into Panel Pro, and once you've configured, in the connections menu, you set up, you can say, okay, here's my NCE system, or here's my Digitrax system connected to JMRI. Well, you connect the buffer USB the same way. It sees it as a node.
Yeah.
Okay. So and it requires a COM port. So once you set that up, LCC menu will appear in Panel Pro, and you just go in there. It's kind of neat too. It's got a traffic monitor on it, so you can see the events as they go back and forth. I had a problem a while back, it was weird. This went on for days. I couldn't get it to detect, what ended up, the long and short of it is, how I said there's 2 connectors and each one has 8 pins that are data. Well, I was configuring lines 1 through 8, and I had it plugged into the second connector.
Mm.
So it was the thing was, I was getting events showing up, which is weird. That shouldn't happen. If you don't even have it in the right connector, as soon as I plugged it in, everything just worked.
Mm.
So.
Now, is that all? Are those boards all addressable? Do you have to set up all that address space and everything? Or?
No, it comes that way.
Okay.
They come with the addresses on them and everything. And as soon as you plug them on the LCC bus and they're plugged into that USB buffer, it recognizes them automatically.
Mm-hmm.
And the thing is, you can name them uniquely. Like mine are named LaPorte West, LaPorte East, Chesterton, and Burns Harbor Yard. So it's easy to know which one you're going in and configure. You don't get confused about it because you can give them unique names. And one of the things they're moving towards, instead of using events, in the future, instead of you seeing event IDs, you can name the event ID. So as you're configuring them, and you'll see this in my future presentation, that when you're choosing a menu selection of how it does what it does with each event ID, it will hang on a second. My wife's calling me. They're going to make it so that there's a text box there where you can actually name that event. So when you're looking at it, you could say detection in West Block 4 LaPorte or whatever. And if you're troubleshooting something, you can see it on the traffic monitor when that one lights up, and then you can adjust your settings based on whether or not it's the right event or not. So, but right now it's numbers and hex numbers and stuff. But don't be afraid of that, because you don't mess with those at all. When you do have to mess with them, like in the future, I'll show you, configuring with the Bob S is more complicated than configuring with the other detection board for touch triggers. So there's some, you got to use 2 lines, and you got to use numbers from the first line in the second line to make it switch on and off. But right next to every number, there's a copy paste button. So when you're making the sensors or making a turnout in JMRI, you just hit the copy button, go into the sensor thing, hit paste, name the turnout, and hit create turnout, and it shows up in a table. So, but I'll show you guys that in the future.
Yeah, that's cool. Good stuff.
Yep.
Another one, are our circuits the only supplier?
There are some people making some other things, like one of the decoder companies, TCS. They've actually got a command station that has an LCC port on it. And there are people that are using some of their TCS throttles over LCC. But as far as, and I think one of the software company, Deep Wood Software, they also make a configuration tool for JMRI for LCC, and he's got a board or 2. But as far as mass production boards, Railroad Circuits is it.
Okay.
And they make good stuff. They're great people. I just wonder about it all the time, because both Dick Bronson and his wife Karen are in their early 80s, and but they're extremely vibrant.
Exactly.
And I heard that he's looking for somebody to buy the business, but you'd really have to love LCC to do that. So
We all use as connectors to hook most things up. I was just curious though if there was any other supplier.
yeah, not in a big way, no.
Okay.
I think Sprague, the Sprague company over in Britain, I think that's where they're at.
Yep.
They've made 2 or 3 LCC boards, but Dicks are cheaper, especially if you're an NMRA member. You get 4+ unit pricing. So
Thank you.
Well, great job, Dan. When do you think you'll have part 2 done?
well, I'm just getting back to work. I've gone through a 3-week bout with a horrible case of carpal tunnel.
Oh, no.
It's almost completely debilitating. And I finally went and got, after PT didn't work, I went and got an injection yesterday.
You can only get 3 of those. I've been there.
Oh, yeah?
Then
Well,
after surgery comes.
so far, no pain today.
Right.
I mean, it's been crippling. It like wake me up at night and stuff. So now that I'm functional again, at least quasi-functional, I'd say probably in a couple weeks. Give me a time to put some slides together.
Okay,
a little
cool.
video show. It's the first time I ever put a video in PowerPoint. So
Yeah, that was nice. It was well done because it sounded like you were doing it live.
Yeah.
It was easy to get confused. But
I,
anyway, yeah, really interesting stuff. I mean, I've got all this stuff invested in doing that on DCC, so it seems like a shame, but it seems much simpler and a little more user friendly.
yeah.
I've got all these stationary decoders and stuff, and they're expensive.
Yeah. Well,
So,
another thing I'm working on is, is a blue flag thing. I saw in one of Tony Custer's recent book where a guy put a flashing blue light on a fascia, and
right.
when you come up to an industry, you push the button and it flashes for a timer,
Yeah.
and then it goes off, and that's to simulate a load being
Uh-huh.
unloaded or loaded.
Yeah.
So I got together over Christmas break with my brother, and we've developed an Arduino program
Yeah.
that uses a black faceplate like you use for a wall plate, and it's got a push button and a green LED on it, and a 10 light blue sequential light on it. So when you're unloading or loading, you push the button, the green light flashes, and the blue light sequentially lights and then unlights, and then a buzzer sounds a train horn type sound, and the green light goes green again. So it's all done. The programming's all done, and it works. I've got
Yeah.
the mock-up is right here,
Yeah. Yeah.
but now I got to consolidate it and get it on that board.
Right. Yeah, that's the Arduino stuff is cool. I've got a little kit that I bought a couple of years ago and messed around with a little bit. There's a lot of potential there.
Yeah. So anyway, I'll show that at some point.
Cool. Well, it's 7:15, so that's probably good for tonight, I'm thinking. Thanks, Dan, for chipping in. And next week, your friend David, what's his name?
Oh, oh,
Sorry, I was muted. His name is Steve Miazga.
Yeah. So Steve's going to
He's
present next week.
he's an N-scale modeler, longtime Sioux Line Historical Society member, and a kind of a guy into tech as well. But the general topic is he's got a finished layout, and it's a beautiful layout, but he likes to build stuff. And so what do you do when officially you're done, but you don't want to be done?
Right.
And it's along the lines of some things Ron has been showing us in his emails for the last 3 or 4 years.
Yeah, it should be real good. He's a master model railroader, so
Right.
yeah.
sorry about that, Greg and Dave. I thought you said Dana. Remember
Oh,
that fellow Dana Zimmerly that offered to do a presentation on that he did, I don't know, at Amherst or someplace on model railroad electronics for dummies.
right. Yeah, I need to contact him because we want to get him on a Saturday.
Yeah.
So, but anyhow, yeah, good stuff and appreciate that. So, yeah, we're set for next week, but after that, we're open. It sounds like Ken is maybe going to do the 30th, did we say? So, and maybe Dan, you'll get in there shortly before or after that with part 2 of LCC. So that's great stuff. We're up to date with everything on the website, or I should say the YouTube channel and everything, and that continues to get a lot of traffic. So we'll have to do something special in May. We'll have our actual 5th year anniversary, which is amazing how fast time goes by. We've been doing this 5 years, and so maybe we'll do it in Las Vegas or something like that.
We'll have a 1 hour flashback video.
Start planning now.
A
Yeah.
Zoom to Vegas.
Yeah. But anyhow, thanks everybody for coming, and we
I think
will
we
see you
should
next
all-
week. Have
I
a
think
great
we should all
Thursday.
catch trains to Vegas.
That's right. That's right. All right.
Thank you.
Thanks again, Dan. Nice job.
Bye-bye.